Alright, so here are our two starter questions. Question number 1 says the figure above shows the graph of the function f with domain between 0 and 4. What is domain again? What are we talking about with domain? X values. And what's the opposite of domain? Range, which is your y values. Okay, so this means we're only looking at x values between 0 and 4. Which of the following statements are true? Limit from the left exists, limit from the right exists, and both sides are the same. Okay, what'd you guys come up with? C. C is correct. Very good. Alright, next one. Which of the following does the limit as x approaches 4 exist? So, does the limit as x approaches 4 exist on this one? Yes. This one? Yes. This one?
No.
No. Why? Okay, what's the technical word I want you guys to get used to saying? Alright, jump's not the technical word. That's how to describe it, but that's not the technical way to describe to talk about what's going on. What's the technical way to talk about why this one doesn't have a limit?
Y values run to two different places.
Not y values. The limit from the left does not equal the limit from the right. That's what I want to hear. Okay? So when you have a jump, like Aaron said, when there's a jump, the technical way to describe what's going on is that the limit from the left does not equal the limit from the right. That's why there's no limit. With me? Okay. So we like D? And we submit. Alright, so let's look at today's module. We are Alright, so today we're going to talk about, what did we say? Or what are the two ways we've done limits? How have we done limits so far? What are the two ways? Graphically and numerically. Okay, so numerically is what we did yesterday. Graphically is what we did the 2 days before. And today I told you we were going to look at doing it how? What's the name of it? What's our approach today? Algebraically. And sometimes they call it analytically. Okay, so when they ask you to do a limit algebraically or analytically, they're wanting you to do the same thing. Okay, so they'll call it one of those two things. All right, so we have a flow chart here that's going to kind of help us figure out how to find limits. Okay. And I'm going to say something today that I'm going to say over and over and over again. Okay? And that is, if you're asked to find a limit algebraically / analytically, the number one rule in finding a limit is plug in. Okay? So that's the first thing you need to know. So you might write that down. Number one rule in finding a limit analytically / algebraically is to plug in your x value. Okay? That's what we want to do. Alright, so that's what it says right there in the blue box, okay? That's what it's telling us to do right here is to evaluate f of a. So what that's saying is they want you to plug in and let's see what type of y value you get, if you get a y value. Okay? One of three things is going to happen as you see below that blue box. Okay? First thing is, if I plug in my x value and I get a y value, okay, what does it tell me?
You're done.
I'm done. Okay, the answer I got is my answer. So for example, here's an example. Limit as x approaches 3 of, let's go with x squared minus 1 over 5x. Okay, so if I ask you to evaluate that analytically / algebraically, what are we gonna do first? What we just said, the number one rule in finding a limit analytically or algebraically is? Plug in. So let's plug in. I plug in 3 to the top. That gives me 9 minus 1, which gives me 8. I plug in 3 to the bottom, and I get 15. So I get 8 over 15. So it's wanting to know which one of these scenarios did I end up with when I plugged in. So what did I end up with?
8 over 15.
I ended up with 8 over 15, so which one of these 3 scenarios does that fall in? The first one, second one, or the third one? Which one is 8 over 15? Is 8 over 15 a number? Is 8 over 15 0 over 0? Or is 8 over 15 not 0 over 0? Which one of those 3? It's a number, okay? And what do they tell you when you get a number? I'm done. So what does that mean 8 over 15 is? That's my answer, okay? That's the solution to the limit, okay? So again, number one rule in finding a limit is plug in. And if I get a number, what does that mean?
You're done.
I'm done. And the number I got is what? My limit. Okay? So in this case, plugged in, I got a number. Since I got a number, that means I'm done, and the number I got is my limit. Okay? So somebody verbally describe what I just learned. Okay? Verbally describe what this is telling me. Okay? You know, the other day we did that matching thing. Okay? One of them was a verbal description of it. So what's going on right here? Somebody give me a verbal description of that right there. What does this tell me right here? I'm getting 3. So how did they say it the other day? Instead of approaching 3, what did they say? Closer and closer to 3. Since there is no minus or plus up there, that means we're getting closer and closer to 3 from both sides. So as x gets closer and closer to 3 from both sides of this function, my y value is getting closer and closer to what? 8 over 15. Okay, and that's what we need to be able to do. We need to be able to understand what it is we're actually finding. Okay? So, that's the first one. It's easy. You plug in, you get a number, you're done. That number is your limit. Question on that? Okay. Second one. I plug in and I get 0 over 0. Okay, so here's an example of that. I have the limit as x approaches 1 of x squared minus 1 over x minus 1. Number one rule in finding a limit algebraically / analytically is plug in. What happens? What do I get when I plug in? I get 0 on the top. I get 0 on the bottom. Okay? Whenever I get 0 over 0, that means I have more work to do. Okay? And we'll deal with that later. We're not going to deal with that today. Okay? But if I have 0 over 0, that means I've got more work to do. Okay? So that's the second one. Plug in and I get a number. I'm done. And that number is my answer. Plug in and get 0 over 0. That means I'm probably going to be able to get a limit, but I got more work to do. Okay? Those are the first two. Last one. I plug in and I get not 0 over 1. Instead of not 0, I like to say number. So I plug in and I get a number over 0. Okay? So, example of that one. I have the limit as x approaches 3 of x squared minus 5 over x minus 3. What do I get when I plug 3 into the top? 4. What do I get when I plug in 3 into the bottom? I I get 0. Okay? So this is the situation where I have not 0, I prefer a number over 0. So I'm running into the situation where I have a number over 0. Okay, and it says this graph has a vertical asymptote at x equals a. So in this case, where's my vertical asymptote? Not 4, 3. Wherever I'm approaching, that's where my asymptote is. So since I'm approaching 3, then that means I have an asymptote. So what does that mean my graph has to be doing as I get closer and closer to the asymptote? What are my only options if I'm approaching an asymptote? What's the only thing a graph's going to do? What?
Go away.
It's not going to go away. What's my graph going to do as I get closer and closer to an asymptote? Well, let's graph it and see what happens then. Because we should know what happens when we get closer and closer to an asymptote. Alright, so control divide. I've got x squared minus 5 over x minus 3. Enter that. Okay, let's zoom out, menu, zoom out, we zoom out, and we escape. So, as you can see, 3 is right here. I've got a vertical asymptote. On both sides of that thing, what's my graph doing as we get closer and closer to that asymptote? It's not a trick question. What's my graph doing? Going towards infinity or negative infinity. So, if I get a number over 0, that means I'm dealing with an asymptote. Can I have a limit if I'm approaching an asymptote? Excuse me.
No.
No, because what's the only thing my graph can do? Go to infinity or go to negative infinity. So, if I'm approaching an asymptote, I know my limit does not exist. Okay? Now, in the 0 over 0 scenario, what do you think's happening there? What do you think is going on with my graph at that spot if I get 0 over 0?
Hole.
There's a hole. Good. So, if I get 0 over 0, that means we're dealing with a hole. If I get a number over 0, that means we're dealing with an asymptote. Okay? And if I get a number, what does that mean? My answer is my limit. What does that mean graphically? Do I have a hole or a limit? No. I have no issues with my graph if I ended up with a number. Okay? I only have issues with my graph if it's 0 over 0 or a number over 0. Okay? So, when we're finding limits analytically / algebraically, first thing we're going to do is plug in. And one of 3 things is going to happen. What are the 3 things that can happen?
Get a number.
I get a number, and if I get a number, what does that mean?
That's your answer.
That's my answer. What else?
0 over 0.
0 over 0, okay, which means what? I've got a hole, I need to do some more work, but I should be able to get a limit. Third one,
Number over 0.
number over 0, which means I have an asymptote, and that means my limit does not exist. Very good. Questions on that? All right, so that's all I want off of that little sheet today. We'll come back and revisit it at some point. But now we're going to move on to the properties. Alright, so here are my properties. Okay, and it's on your module, on your device. Okay, but we'll walk through it real quick. And here's the deal about the properties. The properties, hopefully, to you, make common sense. You're like, oh, well, that makes sense. That's what I would naturally do. Okay, so on the properties or limits, hopefully you'll find that they're all what you would do naturally anyway. Okay? Alright, now, I want to point out something here before we get into the properties. It says usually X, Y, Z, U, V, S, and T will represent variables. Okay? And then A, B, C, K, and L will represent constants. Okay? So that means the answer to a limit is usually going to be represented by one of these five. Okay? And then variables in the problem are going to be represented by those seven. Okay? That's really not that important, but I wanted to throw that out there to you anyway. All right. So, first one. I have the limit as x approaches c of k equals k. Let me write it up here so it's a little bit bigger. All right, limit as x approaches c of k equals k. Okay, so again, what does c represent? Yeah, that C represents a number. What does K represent? A number. So what it's saying is if I take the limit of a number, what am I going to get? I'm going to get that number. That's what it says. So for instance, if I had the limit as x approaches 10 of 5, what's my answer going to be? 5. Okay, that's my first one. So the limit of a number is always that number. Questions on that one? Okay, next one. Limit as x approaches c of x equals c. Okay, and this kind of goes back to what we talked about. So if I have the limit as x approaches c of x, that's going to equal c. So again, what does c represent? That's a number. What does x represent? That's a variable. So if I have a variable, what am I supposed to do with c? What's the number one rule? Plug it in. So I'm going to plug in. So when I plug c into x, what do I get? I get c. So limit as x approaches 10 of x, what's that limit going to be? 10. Number one rule in finding a limit is plug it in. So all I have to do is plug in 10. When I plug in 10, I get 10. Again, most of these are so easy, you're going to have trouble with them because they're so easy. And that usually happens in calculus. You guys, we do some tough stuff, and you guys are pretty good at the tough stuff, and then you get something that's easy, and you're like, it can't be that easy, and then you screw it up. Okay? So that happens sometimes. All right, next one. Limit as x approaches c of k times f of x. Okay, again, c is a number, k is a number, and then I've got a function there. Okay? They're telling me this is equal to k times f of c. Okay, they're telling me that's equal to k times f of c. So what we really need to notice is what happens to that. What? It stays the same. That's all they're wanting you to see. So if I have the limit as x approaches 7 of 2 times f of x, what's that going to be? 2, not f of x, f of 7. Okay, so all they're wanting you to know is if there's a coefficient, what happens to the coefficient? It stays the same. That's all that property is wanting you to know. All right, next one. Alright, so what's this one telling you? And again, it's really basic. So don't overthink it.
Sub in C for X.
Say it again.
Sub in C for
We are subbing in C for X, but what it's saying is, if I have something plus or minus something else, how do I handle it? Yeah, you're really not doing anything. So what they really want you to understand is the limit as x approaches c of f of x plus or minus g of x. That can be broken up into two separate limits is what they're really wanting you to see. Okay, so they're wanting you to understand that if I have something plus or minus something else, that I can break it up into pieces and work each piece by itself versus working it together. Make sense? So, for instance, if I had the limit as x approaches 4 of 2x plus cosine of x, how else can I think about this? How else can I rewrite it? What is this telling me I can do with that?
2 times 4 plus cosine of 4.
Well, you're going ahead, a step ahead of where I want you. I want the step that's in between. Okay, I want to use that right there. Okay, what is that telling me I can do to this?
You split it up.
I can split it up. That's what I want to hear. So I can split this up. I can split it up into both of those. Okay, because what's going to happen is sometimes I have to split it up in order to work it out. Okay, because what happens is I can always plug something into this and have no problem, but I might plug something into this and it causes me a 0 over 0 or a number over 0. So instead of working it all together, I separate it, take care of this, and then go work on this and then put them together. Okay, so that's what we need to understand from that one. And you'll see that in a little bit with another problem. Okay, next one, saying the exact same thing except instead of something being added or subtracted to something else, what's going on? It's being multiplied. So that means I can rewrite it as two different limits that are being multiplied together. Okay, same thing as this, except instead of adding or subtracting, now we are multiplying the two things. With me on that?
Mm-hmm.
Okay, and then this one's saying the same thing, except what are we doing with those two? We're dividing. Okay, so I can separate them into one limit divided by the other limit. Okay? All right, questions on these properties? Again, they're pretty basic. You know, it's, to me, sometimes we don't even need to go over them, but we do. All right, next one is the limit of a composite function. Let's talk about the word composite function. What does the word composite function mean to you? Because that's something we'll use in here quite a bit this year, so we need to know what a composite function is. What's a composite function? All right, Aaron, what's a composite bat? You don't know what a composite bat is?
Oh, you said a bat?
A composite bat. What's a composite bat?
It's like,
You don't know? Yeah, you do. What's a composite bat? Anybody play baseball in here? No baseball players in here? Okay, composite bat is when I take a bat that's made of two pieces and I take one piece and stick it into the other one. So it's two pieces put together. Okay, so that's what's going on with a composite function. Composite function is when I have one function inside of another function. Okay, that's what's going on here. Okay, so it's telling us how to take the limit of a composite function. Okay, they wrote it as, their notation in this one's a little bit funky, in my opinion. They have the f of g notation. I prefer the f of g of x notation. Which one are you guys more used to? Top or the bottom?
bottom.
bottom. Yeah, I'm more used to this, but these two things mean the same thing. Okay? I'm used to this, but if you see this, just know that it's talking about this. Okay? So notice that G is inside of F, and that's what makes it a composite function. Okay? So an example of that would be, let's say I have the limit as x approaches 8 of sine of x, and then that thing cubed. So what's my inside function on that one? What's the function that's inside another function? Or what's the outside function? I'll let you give me either one.
The cube.
The cube is what? The cube is the outside function, so that means what has to be the inside function? Sine of x. Okay? So if you match it up with this, then that means g of x is the sine of x, and then f is the cube. So I have something inside of something else. Okay, so let's see what it says. It says it equals f of the limit of g if f is continuous at that point. So what does that mean I have to do? What is that telling me I have to do to get the limit of a composite function?
What was it?
Right here, it says, in order to evaluate the limit as x approaches c of f of g of x, I need f of the limit as x approaches c of g. So what is that telling me I have to do? And in what order? Say it again. Kind of break them apart. But notice, what's the only one I'm taking the limit of? G, which is what part? The inside. So that's telling me I need to take the limit of the inside part and then take that answer and do what? Plug it into the outside part. So that's what I want you to understand. Okay? So if I do this, it's saying I need the limit as x approaches 8 of sine of x, and then I'm gonna take the answer to this and then do what with it? I'm gonna plug it in to the cube part, so that means I'm gonna take all of this and cube it. Okay, that's what it wants to know. So you take the limit of the inside part, take that answer, and then plug it in to the outside part. Make sense? So that's what they want on a composite function. All right. Questions on the properties, questions on the limit of a composite function. We're gonna look at one more thing, and then we'll probably go check out books because we haven't done that yet. Questions on that? Again, this is on there. You can come back and revisit it if you need to. All right, the next thing we're gonna talk about is the squeeze theorem.